Our today's experiment is verification of basic logic gates. A digital logic gate is an electronic circuit which makes logic decisions based on the combination of digital signals present on its inputs. And these digital logic gates can have more than one input. Inputs A, B, C, D, etc. but only one output. Today we will be verifying 6 logic gates: AND, OR, NOT, NAND, NOR and XOR. Okay. The AND gate that we are using today is a 7408. Okay. 74 series, it is a TTL logic. There are many different logics like RTL logic, ECL logic, etc. This 74 series indicates that it is a TTL logic. Okay. So from the data sheet, 7408 is given as the AND gate. An AND gate, and this IC is having 14 pins. Pin number 7 is ground and pin number 14 is VCC. Pin number it is having actually 4 gates. It is having. It is one IC 7408 IC. It is having 4 gates in it. And its inputs are 1, 2 is inputs and 3 is output. For the second gate, 4, 5 are the inputs and 6 is the output. For the third gate, 9 and 10 are the inputs and 8 is the output. Similarly, 12 and 13 are the input and 11 is the output. Okay. See, its VCC is always 5 volts. We have to give 5 volts VCC. So for performing this experiment, we need all 6 ICs, some 2 mm patch cords, okay, and then one breadboard. We need a 5 volt power supply also. This power supply is inbuilt here. We will make use of this inbuilt 5 volts power supply, okay. And for inputs, what we will do, there are some logic data input switches are there here. Okay, you can see them. They can give both inputs, like 0 and 1, both the inputs it can give. I will show you how. See, this is the power supply. Okay. Now you can see that when I press this one, it is either glowing red or green. Okay. Red is high and green is low. If you can distinguish the color, green is 0 and red is 1. Okay. And similarly here I am having some output LEDs I am having. Okay. And the output I will give at this point and this particular LED will glow. Okay. And depending on if the output is 5 volts, then the LED will glow. And if the output is 0, the LED will not glow. But here what will happen? The LED will glow in green if the output is low. And if the output is high, the LED will be red. Okay. So I am taking a 7408 IC. Okay. It's written 7408. Okay. And you know its pin numbers. There's a notch here. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It is a 14 pin IC. Okay. Pin number 14 is VCC and pin number 7 is ground. Okay. Now I will connect it in the same way in this Raven. Okay. I will have to, what I will do? I will place it like this and then I will press it. Okay. Now it is connected in the breadboard. Now I have to give 5 volt supply to it. Before giving the power supply, always switch it off. Okay. Now it is. VCC, and this is the ground. Pin number 1, 2 are the inputs. Okay, inputs I will take from this place. Pin number on this input. Two is another input. Okay, and pin number 3 is output. Okay, now this circuit connection is over. Now I will switch it on. Now I will verify the gate. Okay, there is a AND gate inside this IC, and I will verify that one. See, input is either 0 or 1. Okay, since it is having 2 inputs, it can have 4 combinations, either 0 0, 0 1, 1 0 or 1 1. Okay, so now it is glowing green, so it is having a input of 0 0. Okay, when the input is 0 0, output is coming 0. Now the input is 0 0. By pressing this input switch, see, it will become 1. Now I have pressed it, it has become 1. So the input combination is now 1 0. Still output is glowing green, means it is 0. Okay, now I will press this one. So it is now, my input is 0 1. Still output is low. Okay, now I will press both the inputs. See, output has become red. Okay, when both the inputs are 1, the output is becoming 1. Okay, so what is the truth table for this AND gate? When input is 0 0 or 0 1 or 1 0, the output is 0, and when the inputs are both are 1, the output is 1. So this is nothing but an AND gate. Okay, AND gate, or you can say that it is a multiplication gate. Okay, so in this way you can verify all the 4 gates present in this one IC, 7408 IC. Okay, now we shall move for the second IC. See, whenever you are removing any IC from this breadboard, you have to be very careful. You will first of all switch off the power supply, and with the help of a pen or pencil, you just have to, in this way, you raise it like this. Okay, now it is rising. Then you remove it with the help of your hands. Okay, this is how we will remove an IC. Now we will see the truth table of a OR gate. Okay, 743T OR gate that we are going to test now. See, this is now I will press it like this. Now it is connected, 7432. Okay, now switch it on. When both the inputs are 0, the output is 0. Now both the inputs are 0, the output is 0. Now we are making 0 1, output is 1, and 1 0, the output is 1. Okay, when both the inputs are 1, still the output is 1. Okay, see, it works just like an addition table. 0 plus 1 is equal to 1, 1 plus 0 is equal to 1, and when both the inputs are 1, then also its output is 1. So it is an OR gate, or we also call it as an addition gate, sum. Okay, it gives the addition of 2 binary numbers. So that is how A7432 works. Okay. So in this way you can test all the 4 ICs also, 4 gates in this IC also. Okay. Now the third IC in today's class is 7404. Okay. 7404 is a NOT gate. Okay. Now I will press it. Now this is a 7404 IC. Okay. Here again I have connected the power supply, and then you see pin number 1, it is having only one input and one output. Okay. Pin number 1 is input and pin number 2 is output. Now we will see the truth table. When input is 0, output is coming 1, and when the input is 1, output is coming 0. Okay. You just see. So it is working just like an inverter. Okay. Output is the invert of the input. Okay. So this particular 7404 IC is having 6 logic gates inside this IC. All the 6 can be verified. We are here verifying only one gate. Okay. Our next IC is a 7400 IC. Okay. It is also called as a NAND gate. It is also having 4 gates in this IC. Pin number 1 and 2 are inputs and 3 is its output. And pin number 7 is ground and pin number 14 is its VCC. Okay. Now I will connect it in this way. Okay. Now I will give pin number 14 is VCC. Pin number 7 is ground. Pin number 1 is input. Pin number 2 is also another input. Okay. And pin number 3 is the output. Now this pin number 3. Okay. Now I will switch on the power supply. So the truth table of a NAND gate says that its output is 0 wherever both the inputs are 1. Okay. Otherwise it is a 1. Now we will verify it. Now it is 0 0. You can see that its output is coming 1. Now 1 0. Still the output is 1. Okay. It is 0 1. Still the output is 1. And now both the inputs are 1, the output is 0. Okay. This is how a NAND gate works. Now we shall verify a NOR gate. Okay. 7402 is a NOR gate. Okay, this is how a NOR gate is now connected. NOR gate is having 2 inputs and 1 output. See, its truth table says that whenever both the inputs are 0, then only its output will be 1. We will verify it now. See, when both the inputs are 0, then the output is 1. Okay, and whenever for all the other inputs, its outputs will be 0. 1 0 it's coming 0, 0 is 0, and 0 1 is coming 0, and 1 1 is also coming 0. Okay, only when both the inputs are 0, then only its output will be 1. Okay, whenever both the inputs are 0, the output is coming 1. Okay, see, one thing is different about this IC. For all other ICs, pin number 1, 2 were the inputs and 3 was the output. But in this case, pin number 1 is the output and 2, 3 are its inputs. Okay. Similarly, pin number 4 is the output and 5, 6 are the inputs. Like that. So before connecting, you have to check all these things. The last IC in today's class is 7486. Okay. Now we have connected a 7486 IC. See, its pin number 1, 2 are inputs and 3 is the output. And its truth table says that whenever both the inputs are same, means the output will be 0. Okay, whenever both the inputs are same, then the output will be 0. See, 0 0, the output is coming 0. 1 0, it is 1, and 0 1, it is 1, and both the inputs are 1, the output is 0. Okay, when both the inputs are 1, you can see that the output is 0. Okay, now you have seen the truth table verification of all the 6 gates. In this, the 4 gates are called as basic gates, and or not, these are all called the basic logic gates. And NAND and NOR are called the universal gates. Okay, they are called the universal gates because you can get all the basic gates by using these universal gates also. That is why they are called the universal gate. That means we can actually realize a AND gate using only NAND gates, or we can realize a OR gate using only NOR gates also, like that. That is why they are called as the universal logic gates. Okay, now we will do a half adder circuit. A half adder circuit, it consists of 2 inputs, okay, and both are binary numbers, like either it is 0 or 0 and 1. So when the inputs are 0 or 1, it can have how many combinations? If the inputs are 2, it can have 4 combinations. Either it can be 0 0, 0 1, 1 0 or 1 1. Okay, and you know the binary addition also. In binary addition, 0 plus 0 is equal to 0, 1 plus 0 is 1, 0 plus 1 is 1, and 1 plus 1 is equal to 10. 1 plus 1 is equal to 10 means what happens? Your sum is 0, carry is 1. Okay, so accordingly we will build a circuit. If you can see the truth table of the gates that you have already performed, you can very easily understand that for this sum part we have to take a 7486 IC, and for carry part we have to take a 7408 IC. Okay, so now we will connect a circuit in this way. So for performing this half adder circuit, I need 2 numbers of ICs, some single strand wires, and some 2 mm patch cords. Okay, and then a universal development system where a 5 volts inbuilt power supply is already there. Okay, and some logical inputs and outputs. Okay. Now I have inserted the two ICs 7486 and the 7408, and now I will do the connections. See, for the two ICs I have to give two power supplies, two 5-volt supplies. So what I will do, this 5-volt supply I will take a row, and this ground also I will take in a row. So this whole row is now a 5 volts and then ground. Okay. Now I will take this 5 volts from this to here. 5 volts. For 14 number pin is the plus 5 volt supply. This is 5 volts. Okay, now I will connect the ground. Okay, now I will take inputs A and B. So pin number 1 and 2 are inputs. And pin number 3 is output. So this is a 7486 IC output is sum. Okay, for the sum I will take this output. Pin number 3. Okay, and the same inputs A and B I have to connect to 7408 IC also. For that, what I will do, I will insert a single strand wire here. Okay, and I will take it as input A. Same inputs I have taken. And for input B. And pin number 3 is output. Okay, so the circuit connection is now over. So this is my sum. This is the sum of the half adder, and this is the carry of the half adder. Okay, plus 5 volt supply I have already given. I have properly connected the grounds. Now I will switch it on. Okay, now both the inputs are 0, 0. Oh, and see, this is the sum and this is the carry, and both are now 0. When the both inputs are 0, sum is 0 and carry is also 0. Now I will make input A 1. Okay, you can very well see that sum has become 1 and carry is now 0. Okay, now I will make input B as 1. See, input B is 1 and sum is 0, sum is 1 and carry is 0. Okay, now I will make both the inputs as 1. Okay, now you can see that carry has become 1 and sum has become 0. Okay, so my truth table is now verified for a half adder circuit. Okay, now we shall go for a full adder circuit. Full adder is a little complicated than a half adder. See, you can see very well that this is the circuit of a full adder circuit. There are 2 XOR gates, 2 AND gates and 1 OR gate. These are all needed for a full adder circuit. From the experiments that you have already performed, you know that one particular IC contains 4 gates, okay, So now I have to take 3 ICs, one 7408 IC, one 7486 and another 7432. Okay, now I have constructed a full adder circuit. For it I have taken 3 ICs, one XOR gate or 7486, one AND gate or 7408 and one OR gate or 7432. These 3 ICs I have taken. We all know that each IC contains of 4 gates. Okay, so for this full adder circuit I need 2 XOR gates, 2 AND gates and 1 OR gate. Okay, here I have taken 3 inputs. 3 inputs from the logic inputs I have taken 3 inputs. Okay, and I have constructed the circuit. For all the 3 ICs I have to give this power supply and ground 5 volts I have taken, and then I have given the outputs to this output LEDs. This is the sum and this is the carry. Okay, so now we will see the truth table verification. For the truth table verification, if the input consists of 3 inputs, it can have 8 possibilities. Okay, if the inputs are 3, then the input possibilities can be 8 possibilities are there. Either it is 0, 0, 0. Okay, we will see them all now. When the inputs are, all the inputs are 0, 0, 0, then sum is 0 and carry is 0. Okay, and any one of the inputs is made 1. Okay, you can see that the sum has become 1 and carry is 0. If both the inputs are made 1, then carry is 1 and sum is 0. 0, 1, 0 gives you 0 and 1, and now when both the inputs are 1, okay, you see that carry is 1 and sum is 0, and when all the 3 inputs are 1, you just see that the sum is also 1 and carry is also 1. Okay, this is how a full adder circuit is implemented.